Hello and welcome to part 2 of our chapter 4 with summary statistics. Here we have 4.5, spread, which we're going to start talking about quartiles. So here we're going to look at two different sites that are measuring particles of matter in the air samples at two different sites, sites 1 and sites 2. Both sites have a mean of 36, but site 1 exhibits a much greater variability. We would miss the high pollution days if we relied solely on the mean, right? So if the mean is 36 for both sites, we'd say, oh, they're very similar sites. When we actually look at the data presented to us, we can see that the spread range here is a lot greater than the spread in range here for site 2. And if we, like we said, we just relied solely on mean, we wouldn't really get the full picture of the actual high pollution days. So when we talk about spread, we're going to talk specifically about range. Range, when we talk about it, is going to be the maximum minus the minimum. Illustrated example of this with our sites is if we take site 1 and we have our range of 22 to 68, we have a range of 46. Site 2 has a range of 32 to 40, so 40 minus 32 and 8. This would be the range for each site. Be aware though, the sample range will tend to underestimate the population range. We always want to supplement the range with at least one additional measure of spread. You just don't want to always just say this was the range and kind of be done. You always want to add more to it. Now we're going to move to quartiles. So just like the range we were talking about, where we have the minimum and the maximum, well, now we have quartiles. Think of quartiles like a quarter. Like if you have $1, 4 quarters make $1. So when we talk about quartile 1, we're going to short that down to Q1. It cuts off the bottom quarter of the data, equals the median of the lower half of the data set. Quartile 3, or Q3, cuts off the top quarter of the data. It's the median of the upper half of the data set. And our interquartile range, or IQR, is equal to the Q3 minus Q1, and it covers the middle 50% of the distribution. So let's go ahead and look at this here. So here's our data set that we've been kind of using quite a bit, where we have our spread from 5 to 52, and the range we would say on this one is going to be 52 minus 5, which equals 47. Now we're going to talk about the quartiles. So first thing we're going to do when we do quartiles, you're going to want to find that median, right? And we found the median before. It's the value we found here, which is going to be 27.5. But the median would be here. What this does is it actually divides the data set in half, right? There's 5 numbers on this side, 5 numbers on this side. And now, when we look at the quartiles, they're going to cut off the bottom quarter of the data, and then you're going to find the median of that data set. So as you can see here, if you have think about this as its kind of own individual data set, where it has 5 numbers, and the median value here would be 21, right? And this would be, of the whole data set, the first quarter, right? 25% in the first quarter value, what the median is. So we would say our value here for Q1 is 21. Same thing here on the other side. If we imagine this as our own data set, and we look, there's 5 numbers, the median value would be the middle number, so this one 42. Now it would be Q3. And this would be cover, think about like the 75, the upper part of the data set. So we have our Q1 being 21, our Q3 being 42, and now to figure out our IQR, which covers this middle data set right here, we take our 42 minus 21, which equals 21. So we have an IQR interquartile range of 21. Quartiles and Tukey's hinges. So here's an example that, and going forward, this is how all problems should be worked out. We are always going to exhibit Tukey's hinges on this. Example 2 here, here's data are metabolic rates, so calories per day, and our N equals 7. So we've seen this data set before as the one where we fat fingered before, but now there's no fat finger. And we have a median value of 1614. So when n is odd, you include the median in both halves of the data set. So because this is odd, we include the median in both halves of the data set. Don't exclude it. So I kind of outline the bottom half and the top half for you, including the median in there. So then to find our value for our bottom half here, it would be, our mean is going to be the value of these two averaged out, which will be 114.49.5 being our Q1, and the middle value between these two numbers, which is going to be 1729, or our Q3. A little tongue-tied there. With those, we can now give you a 5-point summary. The 5-point summary will be the Q0, Q1, Q2, Q3, Q4, which is everything we just went over. The minimum value will be your Q0, 25th percentile is the Q1, the median is Q2, Q3, 75th percentile, and Q4 is the maximum. And it's everything we just did to get those values. When we have our IQR, now we can start using that 5-point summary to draw a box plot. So you calculate the 5-point summary, you draw a box from Q1 to Q3 with a line at the median. You calculate the IQR from your Q1 and Q3, and you can add your fences. And we have two fences. We have a lower fence and an upper fence. To figure out where your fences go, you take your Q1 value minus 1.5 times the IQR. For your fence upper, you take your Q3 plus 1.5 times your IQR. Do not draw fences. Determine if any value lies outside fences, outside values. If so, plot these separately to determine the values inside the fences, inside values. You draw whiskers from Q3 to the upper inside value, and you draw whiskers from Q1 to the lower inside value. So let's go over an example to go over this in a little bit more detail. So here's our illustrated example for our box plot. Here's our data set that we've been using so much. It's getting run down now. So we have to create our 5-point summary from this. Our 5-point summary is going to be 5, 21, 27.5, 42, 52. And we box from 21 to 42. So it would be like a box like that with a line at 27.5, right? So I kind of showed you what that looks like there, but when we put it on a graph, we have, our X and Y values here, it's going to look like that. And we know that when this is kind of filled in, this top part here is going to be representative of the Q3, our Q2, and our Q1. To figure out our IQR, we take the Q3 minus Q1, what we did earlier. You got a value of 21. And now we're going to plug that value into our fences to find our upper and lower fence value. So for our upper fence, it's the Q3 plus 1.5 times the IQR, which is going to look like 42, plus 1.5 times the value of the IQR, which is 21. Remember, our orders of operation first. We're going to want to multiply this out, then add it to 42, and you're going to get a value of 73.5. Same thing for the lower. Multiply this out, minus it from 21, and you get a value of negative 10.5. You're going to go back to your data set, and you're going to look. Let's start at the top. We have an upper fence of 73.5. And you look at your data set and you realize no value is over 73.5. We don't have anything above 73.5, so nothing is above our upper fence. And we look at our lower value and nothing is below our lower fence. If there was a value above or below, we would consider that to be an outlier. And if we had an outlier, then we would mark that on the graph with a dot to where it goes. So now we have our upper inside value and our lower inside value, our lowest value being 5 and our upper value being 52. And we would mark that on the part with our whiskers. If I was really handy, I'd be able to erase that, but you'll be able to kind of see from here that here's an actual box plot and box and whiskers here for you. So here's your Q3, your Q2, your Q1, and you have your lower inside value with your whiskers coming down and your upper inside value. So if you were to look at a box plot, you can clearly see where everything is. You see where your upper and lower values are, where the box itself is encompassed of your Q3, Q2, and Q1, Q2 being the line donated in the middle. An illustrated example for box plot 2. Here's another data set. And if we were to go through this data set, our 5-point summary, where we're going to have our lower, higher value, find our median value between here, which is going to be your 25.5. And then when we do this, we find our middle values in between each one, and there's your 5-point summary to draw your box. IQR is going to be your Q3 minus your Q1, and you get your value. To find our fences for them, you plug the numbers into the formula, so your Q3 plus 1.5 times your IQR, which is going to equal 28, plus 1.5 times your value of 7, which is going to equal 39.5. Your Q1 minus 1.5 times your IQR, plug that into your formula, and you're going to get 11.6. When we look at this particular set, when we look at our lower fence, we see that our lower fence should be a value of 11.6. When we look at our data, we see we have a data point below that. And when we look at our upper fence of 39.5, we see we have a value also above it. So we would say our upper inside value is going to be 31, and our lower inside value is going to be 21, because that's the actual values that are next in line that are not above or below our fences. And you draw your whiskers to those, shown here. So here's your box plot with our inside value of 31, right, because it is the one that's actually a true data point that's not outside the IQR fence limit. And the value that is above the fence limit is drawn as a dot shown above. Same thing here. We have our lower value as a dot below, and your inside value here. Our box being here's your Q3, Q2, and Q1. And this is an illustrated example of the box plot showing you values that are outside of our fence limit. So here's one more example. Box plot 3. We have 7 metabolic rates. When we do our 5-point summary, once again, we have our lower and our maximum. We're going to find our middle value being 1614. And then we're going to include the using Tukey's method, right? So this one, that's your first box for the lower, and your box for the upper. You're going to find your middle value here for your Q1, and your middle value here for your Q3, which is just adding these two points together, your data, and dividing them out and getting the average, which is shown here in your 5-point summary. Figure your IQR, you take your Q3 minus your Q1, and you get your IQR as 279.5. To figure out our fences for our box plot, so our upper fence, once again, is Q3 plus 1.5 times the IQR, which is going to be 1729 plus 1.5 times 279.5, which is going to give you your value here. When we look for upper limit, we can look at our max value, and we can see that no value is above that limit. So then we calculate our